Okay, Newton's first law. Every object either 1 remains at rest or 2 keeps moving at constant velocity unless acted on by an overall force. That's it. Okay, great. But what does it actually mean? Well, the first bit, that kind of makes sense, right? Newton's telling us that every object remains at rest unless acted on by an overall force. Well, that kind of makes sense. Like me right now, okay, if I don't move, I'm at rest, the overall force on me is 0. Yeah, that makes sense. Because I'm standing on the ground, right? I'm being pulled downwards by my weight, or gravity. Okay? And I'm being, let's do this different colour. And I'm being pushed upwards by the floor pushing on my feet. It's called a reaction force. That's the ground pushing on me. The reaction force is the same as the weight force, therefore they cancel out, and the overall force, overall is a very important word, the overall force on me is 0, so I don't move. I remain at rest. Okay, great, that makes perfect sense. But it's the second bit that is counterintuitive and causes a lot of confusion. Newton is telling us that every object keeps moving at constant velocity unless acted on by an overall force. So that means if you're travelling at 500 miles an hour, say, and the overall force on you is 0, you're telling me, Newton, that I'm going to keep travelling at 500 miles an hour. Yes, that's exactly correct. Well, that can't be right. It is right. Let's look at the example of an aeroplane, okay? The jumbo jet. So, you have an aeroplane, more or less, okay? Good enough. It's taken off, it's flying from, I don't know, London to New York, it's going over the Atlantic, it's achieved cruising height, altitude, whatever they call it, and it's travelling at 500 miles an hour, constant velocity in a straight line. You're telling me the overall forces on that aeroplane are 0? Yes, they are. I know it seems weird, but if you've got a problem with it, take it up with Newton, and he's probably correct. Right, so what are the forces on that plane? Well, gravity, its weight is trying to pull it back down to Earth, okay? So it's weight pulling it down. So there must be something holding it up. Absolutely. From the force from the wings, lift. I don't want to get into the physics of how air going over a wing creates lift, but it does. And that force upwards from the wings is equal to the weight. So those two forces are balanced. But, of course, it's got these massive engines, right? And they're not switched off when you're going at 500 miles an hour. They're creating a huge forwards force. And that forwards force is called the thrust. Okay? They're still on full power. So what's going on? Why is the overall force 0? Well, it's travelling at 500 miles an hour in this direction. So it's being hit in the face by the air, and that creates a huge drag force backwards. Okay? And when it's travelling at constant speed of 500 miles an hour, all that force forwards, the thrust that the engines are creating, is perfectly counterbalanced by the air hitting it in the face and trying to slow it down and trying to push it backwards. And so you can see that that word overall is very important. The overall force is 0. Newton isn't saying there are no forces on it. He's saying the overall force is 0 because the lift created by the wings is exactly equal to its weight pulling it down. So those two cancel out and the overall up-down force is 0. Same with forwards-backwards forces. The huge thrust created by the engines forward is exactly counterbalanced by the air resistance, the drag. So those two cancel out, which means the overall force on an aeroplane travelling at 500 miles an hour is 0. And therefore, by Newton's first law, it keeps moving at constant velocity. And that's why when you're sitting in the aeroplane, moving at 500 miles an hour, you can stand up and walk around and throw your drink can in the air and catch it exactly the way you would do if you're in a room like me right now. When you throw your can in the air on the plane, which I hope you don't do, it doesn't go shooting backwards as soon as you've thrown it. So it's counterintuitive. It's kind of, for want of a better word, natural to think that there must be an overall force on something if you're travelling so fast. But no, the overall force is 0. There are forces, but that's Newton's first law. Yeah. Very important law.